Hello everyone, welcome to the third day of networking lectures. Today is going to be all about TLS. So far we've built our way up to the transport layer, and we've also talked about how the transport layer by itself is not secure against all sorts of attacks. So today's goal is going to be using all the crypto you learned from the previous unit and applying that to help us build a secure channel on top of the transport layer. So I think that's all I have to say for today, so I'm going to let Dave take over for the rest of the lecture.
Okay, so we taught you about crypto. Let's say you want to use crypto in practice. There's basically two common cases that cover 80% of the uses of crypto. The first common case is, let me call it a sealed blob. This is when we talked about, this is kind of like when we talked about DNSSEC, we're talking about object security. That was like signed data. A sealed blob is data that is both encrypted and authenticated. Like it might be both signed and encrypted under someone's public key, or it might be encrypted with AES symmetric key and had a message authentication code attached. Okay, so this is data that provides both confidentiality and integrity for the people who know the key. That's one really common piece. For instance, if you've got, if you're doing project 2 right now, you've probably got a lot of sealed blobs floating around. You've got like file contents that you want to be stored with both confidentiality and integrity. So you're probably both encrypting and authenticating it. All right. The second common case for use of crypto is a secure channel, a communication channel that can't be eavesdropped on or tampered with. And that's what I want to talk to you about now. So call that channel security. And I want to tell you about how we achieve channel security, how you build a secure communication channel using crypto. And I'm going to do that by talking you through how TLS works. TLS is a protocol that's probably the most commonly used protocol for secure channels. It's a great one. It's wonderful. It's really well designed. There's been a lot of effort put into designing it. You can use it yourself. If you need a secure channel, a good default is you go use TLS. The web uses TLS. Lots of applications use TLS. I want to tell you how TLS works. And then it'll both help you understand how it works and also help you know how you achieve secure communication channel. So what we're going to try to go for is what's called end-to-end security. That means the communication, the protections go from the sender to the recipient. So like it might from my browser to the web server. And there may be intermediaries along the way, like routers, or there may be load balancers, or other hosts along the way. And those they're sort of in the middle, and we're gonna not trust them. We're not gonna trust those intermediaries. So this is the goal of end-to-end security. And TLS is going to deal with eavesdropping by encrypting. It's going to use symmetric key encryption to prevent eavesdropping. It's going to deal with tampering by using message authentication codes and sequence numbers to prevent tampering or replay. And it's going to prevent impersonation by using public key signatures, digital signatures. So we've got confidentiality, we've got integrity. What's missing? Availability. TLS doesn't do anything for availability. It doesn't do anything to stop denial of service attacks. It doesn't stop jamming of your transmission. So a little bit of history here. TLS was previously known as SSL. That was kind of the first incarnation of this. And then it evolved. It's gone through multiple versions, and the latest version is called TLS. So you'll sometimes see people use SSL. Sometimes people call it TLS. They use more or less interchangeably. There's kind of like this remnant. Some people still use the old name SSL. They're really referring to the same thing. And TLS can be used with any application that's using TCP. So the idea is you use this on top of TLS. So you set up a TCP connection. Oh, I said that wrong. Use TLS on top of TCP. You set up a TCP connection, and then the data that's sent over the TCP connection is encrypted and authenticated using TLS. This is used all over the place on the web. If you ever visit a website that has HTTPS, the S stands for secure channel. In other words, it's there for, it implies you're using SSL or TLS. Also, mail servers will protect their communications between them using TLS, using a mechanism called start TLS. If you have a VPN, a virtual private network, many of them are using TLS to encrypt the communication so that your ISP can't see the traffic that you're sending.